Alright guys, welcome back to D-Tech. Today we are going to be taking a look at this Land Rover. It is a 2016, I believe it's an LR4. It's got the 3.0 V6 supercharged. Now the reason that it was brought over to me is to check and see why the check engine light is coming on. The shop that brought it over did a ton of work. They lifted the body to replace the cylinder head gaskets. And I might have a picture just to show kind of the amount of work that's involved when doing that. Now, the trouble codes that it is having now is basically timing codes for all 4 camshafts. Now, that's something you don't want to see after the amount of work that was just done and what's involved when doing it, so on and so forth. Now, the customer did tell me that they ordered and used timing tools because this obviously is going to be a procedure that involves using timing tools. So he wants to know why the codes for timing keep popping up. Now, the other thing about it is it does crank and start up almost right away. No hesitation, no extended crank like other Land Rovers or other make models that when they're out of time, they'll have an extended crank. This starts up pretty well, normal, and it drives with no issues. So he wanted to see if there was some sort of reset or so on and so forth, and again, just see why the check engine light keeps popping on. And to get you a shot, obviously I've scanned this beforehand. Here is the vehicle, it's 16, Discovery LR4, and there we go. We've got a 16, 17, 18, 19, all related to the correlation for the camshafts. Obviously, O2 code, but this is the one that we are worried about or needing to take a look at. And prior to going this deep, I did attempt with the tool to see if there is a cam crank type of relearn. I know on other models that I have dealt with, particularly the 2.0 Land Rovers, anytime I do timing work or cylinder head, you have to do the reset on those or else you will get timing codes. Now, with the Autel, I did not find a reset, and so I just tried to clear it, it drove it, it verified the codes do come back. So my idea is to take a cam crank correlation capture of all 4 cams along with the crank and put that up on a forum, ask for a reference to see if anyone out there has any that match this particular setup, and I'm going to see if the vehicle is truly out of time physically, meaning our base timing, the way the chain sits and is set, is that not in the correct position? That's what I want to verify. So in order to do that, again, we need to get all of our cams and cranks compared to a vehicle that does not have timing codes, and that'll truly tell me if these are out of time or if there is an actual reset that my Autel is not displaying. And again, I say this based off the way it starts, runs, and drives. It almost doesn't seem as if it's out of time, but obviously these codes keep popping up. So I'm going to go ahead and do a crank no start. I like to do base timing inspection, cranking only as if we were manually turning the engine by hand after setting the timing chain. That's where it's going to sit. That's where it needs to be correct initially before any variable cam timing comes into play. And so that's the picture I want to capture. One thing to tell you, it was a little bit of a pain figuring out all the pinouts. The cams are located in the front, a little bit difficult to get to, but not terrible. Crankshaft on this vehicle is extremely difficult. You might want to Google it or whatnot, but a video popped up of having to remove an upper control arm, some exhaust shields, a turbo drain pipe. On that particular model, it was turbo, but a ton of work going through this way, obviously wheel removed and everything, just to get to even the connector. The crankshaft sensor is just buried. The next best thing was try to get it at the computer, and that is also buried there. Now we can see the connectors, but there is not much tug play in that harness, and so I didn't want to go that route. Next best thing is I ended up kind of chasing and going up, and I found the signal wire in the loom. Now it's a little bit difficult, but a tip for you guys: this is a shielded harness. The 3 wires for the crank sensor is shielded, and so I looked for the shielded wire in the main loom and found the signal wire. So that alone took a bunch of time, but now we're all set up. I'll get you on the scope and we'll go ahead and crank this. So that's a cranking waveform, and I'm also going to get one at idle. Alright guys, so today I happen to sort of get lucky as far as what I am talking about. I've been sitting around on this Rover that I scoped, that we have started this video with, waiting for a known good waveform. I haven't had the best of luck online trying to have someone source me one that is very usable. So with that, I kind of just put it on the back burner, but that's when I kind of got lucky. Last night, this customer, which is the first time coming here to me, he was referred to by another shop, asked me if I could take a look at this for check engine light, so on and so forth. I pulled it in, popped the hood, and wouldn't you know, it's the same exact engine with supercharger, so on and so forth. I believe they're 1 year apart, so nothing too crazy. Setup looks the same deal, harness, everything, where I tapped in for the crank sensor. So what I'm doing now, I'm actually looking and checking into his actual complaint, which is actually lean fuel trim codes and an evap code, which I can get you a shot of that. Maybe I'll bring you guys along quickly as to what I'm looking at for his particular concern. But once we get that figured out, I will be taking the chance or the opportunity to get my known good off of this vehicle and finally be able to get an answer on the Rover that's been here for a little bit. So this is a shot of the trouble codes that I got last night, and obviously the ones that we will be concerned with this gentleman's vehicle is the ones in the PCM. And so bank 1, bank 2, let's see, lean, and then that is the evap code that I was referring to. And so what I am doing is trying to figure out where, if we have a actual, let's say, external type vacuum leak, a leak of the crankcase system that bleeds off externally. So the way I do that is by starting to do a smoke test of the system. And just another tip for you guys that are doing this, because sometimes I do see some people at shops where they think they're testing the system, but they could do it a little bit better. What I mean by that is they'll take a hose off and feed, let's say, the smoke machine into a port into the intake manifold, and they'll leave the air boxes the way, just normal. And I understand it's a little bit of a pain to get them off and so on and so forth, but it's kind of useless. What I tell them at that point is it's like trying to put air into a tire or wheel with a big gaping hole on the side of it. You're always going to be feeding air, but you're always going to be leaking. And so if you want to find a leak, you want to cap off an external opening so that you can basically pressurize the system and see if there is an actual leak somewhere else. So that's kind of what you need to do. And so you have to analyze, look at the system, what you're working with, so on and so forth, and the best approach. So on this one, I didn't want to open up any of these just, right now in the beginning. So the approach that I'm going to go with is to feed smoke through one of the intake fresh air sides, and then you have to cap off the other one to create your seal. And so if I was going to go into the intake manifold area, then you would want to cap this off and cap this off so you can seal the whole system and look to see if there's a leak anywhere. So I did this already off camera, and I did not find any external leaks. Now, word of advice, these do contain a rubber diaphragm just like BMWs, and I'll put either a picture or a link or so on and so forth of a crankcase vent valve diaphragm type system. This one does have one. I have done these in the past, so you do need to watch out for that. Normally, those will create high crankcase vacuum because it'll tie your manifold vacuum to the crankcase if there is a tear in that diaphragm. You can sometimes also audibly hear something there. If it's torn, when you feed and get air into the manifold system or crankcase, you will see smoke starting to bleed out of that chamber. I did not see that leak, and I did not find any other external leaks. So my next thing that I want to do, and this engine is cold, so I want to test just by even seeing the evap code to see if the purge valve is leaking, because that is one thing that you won't technically visually be able to see if it's leaking internally and back to the tank. So what I've done is removed this connection, which the purge valve, this is the port for the purge valve, goes down here. The purge valve is located under this foam, and then that hose curls back up and connects here. This thing brings it back to, or ties the fuel tank back there. So this valve, based off service information, it's normally closed when not powered. So I can feed smoke in here and see if I get smoke coming out of here. If I do, then the valve is not sealing, and that's possibly where our leak is going to be. I could also, just to cut time, remove this and feed smoke directly in there and see if it comes out there. So either way will work, but that's the next step that I want to do, since I did not find any leaks anywhere else. Alright, so not sure if you can see on camera, but I've got the smoke machine going. Going to start feeding it in. There we go. And sometimes you'll have to hold this because it'll build up a little bit of pressure. And we're going to keep our eye on that hose there. So we're testing this here on the bench, and what the idea behind this was to activate the valve multiple times and try to see if we could get it to unseat and see if we can get it to where it's leaking. So I used this fuel injector tester, and we jumped it quite a few times and feeding smoke in there, and it would actuate open and close. After a few times, we noticed, and you can see I've got the injector tool unplugged, and so it's de-energized and it's leaking smoke. So finally, after multiple times of activating, we got it to unseat, and that is the reason why we got the trouble code. So it's intermittent as far as leaking or sealing on the valve, but we finally got it to leak. Alright, so now we are going to move on to getting our known good. Pretty much same connections as the Discovery, even tapped into the crank sensor there. One thing that was a little bit difficult or confusing, the crank sensor. According to the diagram and the Discovery, the crank sensor wiring, the 3 wires are shielded, so they're within a kind of like a the 3 of them are inside a black sheathing, let's call it, type of deal that shields it from the rest of the wiring. This vehicle did not have them shielded, even though the diagram showed it. The other thing is, and I usually do not pay attention to wire colors on the diagram, because it can be wrong. So usually I go by the pin numbers. If you see there, it describes the crank sensor signal as yellow and purple. And on the vehicle here, it is not yellow and purple. It is yellow and green. Let's see. As you can see there. And it was the same for the Discovery after had trouble trying to find the harness there. So just a thing to point out, don't make the wire colors your primary thing for identification. Always go by pin numbers, and then when mapping out, to try to accurately get the correct wire. Another thing to quickly point out, it's got a fuse box here, fuse box here. None of these have the fuel pump control, unlike the Discovery. This one is in the rear fuse box, and it's that slot there. That's the fuel pump, 30 amp fuse. With that, let's go ahead and get a crank no start waveform. I've pulled up the Discovery one. I'm using all the same setup, channel, location, so on and so forth. So we can just continue with that and get our known good finally. We'll get it started. Well, sometimes it's hard to get all the residual fuel out of there, so I'm going to take a look at this one first. Alright guys, so here are the results. Now again, this is cold idle, so I pulled up the waveform for cold idle on the suspect vehicle. The one we are looking at right now is the known good. I put up these markers and rulers. That way we can have some reference point. So let's start with the first one here, first marker there, and I'll just switch back and forth and let's look at the each channel back and forth and see if there's an obvious thing. I'm sure you guys will be able to pick up stuff, but first we'll look at basically like distance from this tooth to that marker. There's the bad one. Looks like it's a little bit wider. And then this line to that, it is wider there. And then this green one, a little bit hard to tell there. And then the yellow, again, a little bit hard to tell there. If we now move to the second one, let's look at that section. Again, this is the no good. That's a big difference there. Red, let's see. Looks like it's a little bit wider. Green, again, hard to tell. And then yellow, big time difference there, which you could see it here also. So this is known good, and so yeah, the yellow is also shifted to the left. These two are shifted to the left. Let's just for since we pretty much got it, let's look at this red there. Yeah, let's try to find the green, since that one's a little bit hard in question. Maybe this area here. Yeah. So all of them are shifted to the left, which would make sense since it has codes for all four. Now, normally my true desire is always to get a cranking. Again, it's just base timing as how the engine is set up with the chain when assembled, and if you were to spin it by hand, that's where you're landing. I think these points are the same at idle as it was at idling, but I don't want any variable cam timing to come into play. So I'm going to try and keep cranking this to get the rest of the residual fuel gone. That way I can get a true cranking only waveform to have both to compare to be 100%, but I think we're definitely good to assume and you know, find out what's really going on. Alright, looks like it finally died. Let's go ahead and crank it. Alright, so again, this is a cranking. This is the true one that I'd like to use. One thing to point out, it's crazy how long it runs with the fuel pump fuse removed. These GDI engines, I've experienced that a lot, so it might take a little bit to finally get them to not run, so just keep that in mind. So we'll open up about the same. This is our known good. This is the waveform for crank no start on the subject vehicle. Let's get somewhere about the same. Alright, so this is the known good. We'll go back and forth again. Let's pick out the red. So yeah, red on the bad one's more to the left. Let's look here. Yeah, so known good is more to the right. So looks like kind of close to the idling, but this is a way better, more secure picture. Let's look there. Yeah, more to the left. So that's it. That will 100% tell us the timing is truly off from the crank on all four cams. And lastly, in case you guys wanted some numbers, let's put up our degrees. And we'll use the blue one up top. So that one is 14 degrees. Let's use the bad one, same spot, blue waveform. Wow, almost double. So 32. If you could see up there, up top. So 32 from 14, we're almost double the distance. Let's go to the red. We'll go to the left again. So our bad one is at 70. And we've got 53 for our good one. Then we'll use the green. We are at 70. We are at 88 pretty much. And then the yellow, this one's 132. And this one is 114. So yeah. There you go. There are the actual degree figure numbers that all four are off by.